Hello and welcome to my YouTube channel Statistics with R. In this video, we are going to conduct descriptive statistical analysis, which means to summarize the data in numerical measures. First, let's have a look at the data which we are going to use in this video for conducting descriptive statistical analysis. As you can see, we have the three continuous variables, namely fruit weight, seed yield, and seedling length, along with one categorical variable which is a group. So first we are going to copy our data from the Excel. Let's go back to the R, and with the help of this script we are going to import the data by keeping the name of the data as a sample data. So we will import the data into the R. As you can see, our data is in the data editor, with the first variable as a categorical one and the rest of the variables as a continuous one. So we will run the summary function to analyze the data to compute the summary statistics, which is available within the base R package. After clicking the summary function, we have to give the name of the data within the parenthesis, but we know the first column is a categorical variable, so we will first remove that variable from the data by using the comma. It stands that we are keeping all rows in our data. Then we will write -1, means we are removing the first column from our data. After running the script, you will see on the console portion that the descriptive statistics of the three continuous variables like minimum value, first quartile, median, mean, third quartile, and the maximum value are printed on the console portion. For computing the variance, standard deviation, coefficient of variance, standard error of mean, we have to run the scripts which we are going to run in this video for producing the values of these different measures which the summary statistics have not provided. So first let's compute the mean by using the mean function. The name of the data is the sample. We can use the $sign to see the variables within the data set. So we will compute the mean of the fruit weight. When after running the script, you can see the mean of the fruit weight is 2.207, but we have the two groups. If we want to compute the mean group wise, what we will do, we will attach the sample data with the help of attach function. Then the function which we have to use is the tapply function, which will compute the different measures group wise. In the first argument is the vector where we have to put our continuous variable, which is fruit weight. Now the index here is the categorical variable, which in our sample data is the group. So we will replace index by group. Now the function stands for the different types of numerical measures which we want to compute. Let's suppose we want to compute the mean group wise. We will run the script, and this script will give us the mean of the both groups, mean group 1 and group 2. Now we will copy this function. If we want to compute the standard deviation of fruit weight group wise, we will replace the mean function by simple SD function. SD stands for the standard deviation which we are using to compute the standard deviation. So we will run the function. It will give the standard deviation of both the variable fruit weight group wise. Now if we want to compute the standard deviation of a fruit weight irrespective of the group wise, we will use the SD function. We will give the name of the data, $sign we'll use to see the variables within a data set. Then we'll run the function. This is the overall standard deviation of a fruit weight, and this is the standard deviation of the fruit weight group wise. Now we will copy the function and we will paste the function. Now if we replace the standard deviation by the quantile function, quantile stands for the points which divides it into different ranges of the probabilities. So we are replacing now by SD by quantile function. We will run the function, and we will see $sign. That means these are the different quantiles belonging to the group 1. These are the different quantiles belong to the group second. 0% stands for the minimum value, 25% for quartile 1, 50% for the quartile second, 75% for quartile third, and 100% for the maximum value. Now, let's suppose we want to compute the coefficient of variation. For that, we need two things, one the mean and the standard deviation. I will first compute the mean by storing into the mean value. I will use the sample data of the fruit weight. So I'm computing the mean of the fruit weight, storing it to the mean object. Then I will compute the standard deviation by using the st function of the, we want to compute it for the fruit weight. So we have computed both mean and standard deviation. Then I want to compute the CV, which I will store into the coefficient of variation. Then I will use the parenthesis for standard deviation. As we know, it is the formula is standard deviation, which I have stored in the previous function, divided by mean, and I will multiply it by 100. So after running the script, you double check on object CV, run the function, and you can see the coefficient of variation is 17.16332% for the fruit weight. Now if we want to compute the coefficient of variation group wise, so I will run the object mean underscore groups. I will store, and here I will apply the t apply function again. I will use the fruit weight is my response variable, and the index for which I am going to compute is the groups, and I will replace the function by mean, and this as we have computed it in previous commands, it will give me the mean of two groups. I will paste the function again, but I will replace it by standard deviation because I want to now compute the standard deviation of the both groups. So we are computing mean of two groups by this function, standard deviation of two groups by this function. Now I want to compute the CV. For that I will run the command line standard deviation underscore groups. That means here in this object lies the standard deviation of both groups divided by mean of both groups, and I will multiply this by 100. And after running the script, I will check for again CV, run the object CV. You can see this coefficient of variation in the group 1 is 1.87%, and coefficient of variation in the group second is 4.82%. To compute the range, a simplest measure of dispersion, we have to run the function range, and within the parentheses we will put our one variable, quantity variable, fruit weight. So this is the range which stands for mix. This is the minimum value, this is the maximum value. To compute the interquartile range, we are giving the function IQR, then sample function, then within the sample function we'll give fruit weight. So this is the interquartile range, which is also the difference between the quartile third and quartile 1. So this is how we are conducting the descriptive statistical analysis in R by running a script of summary function, or we can be able to run the script for each individual measures. And the t apply function is the function which will help us to compute the any numerical measure group wise pertaining to any continuous variable. Thank you.